Hello guys, in this video we are going to discuss the solution of the problem remove half nodes. So let us look at the problem statement. The problem statement says you are given a binary tree and you need to remove all the half nodes which have only one child. Return the root node of the modified tree after removing all the half nodes. So for instance, if this is the tree which is given to us, as we can see 7 is a half node and what we need to do is we need to remove 7. After removal of 7, the tree becomes 5, 2 and 8, which is what is being printed, or the in-order traversal of that tree is being printed over here. So that's the problem statement, folks. Now let us discuss the solution of this problem. So in order to solve this problem, we need a mechanism to identify a half node. And once we have identified half nodes, we need to remove this half node and manipulate our pointers. So first let us look at how do we identify a half node. Well, to identify a half node, what we need to do is first we are going to check if root left equals to none and root right is also none. If this is the case, then this is not a half node, rather this is a leaf node, in which case we can simply return root. The second case is if root dot left exists, or rather it is not none. So if root dot left exists and root dot right equals to none, so in this case what we need to do is we need to delete the root node, and instead of root node we will go ahead and send root dot left. So from here we have to return root dot left. Similarly, if root dot right exists and root dot left is equals to none, then in such case we just have to return root of right, since this is a half node. And then let us look at the fourth and final case where both left and right child exist. In such case, this is not a half node. In such case, we are going to return root. So in this way, we will be able to identify whether a node is a half node or not. So in these two cases, the node will be half node, in which case we are going to return root dot left and root dot right. In other two cases where this is not a half node, we are going to return root. So in this way, we will be able to identify half node and we will be able to remove it from our tree. So the removal part is okay, but the other part which we have to address is we have to manipulate its pointer as well. So let us discuss how we are going to tackle manipulation of root pointers. So in order to understand that part, let us take an example. So let us say this is the tree which is given to us and we need to remove all half nodes from it. So let us first identify which traversal are we going to use in order to manipulate our pointers appropriately. So let us first check whether we can use pre-order traversal in order to solve this problem or not. So as we know, in pre-order traversal, we first operate on root and then we operate on left and right child. So now if we are operating on left child and let us say left child turns out to be a half node, so in such case, removal of left node is easy, but manipulation of root pointer will be tricky. And why this will be tricky? Well, this will be tricky because we have already operated on root node and we have moved to left node. Now the root pointer data has to be manipulated. And since we have already operated on root node, it will be a bit tricky in order to manipulate the root node while we are at left node. Because of which pre-order will not give us an easy solution for this case. So we are not going to use pre-order traversal. Please note folks, it is possible to solve this problem using pre-order solution, but the solution will be a bit tricky. And that is the reason we are not discussing pre-order solution over here. Now let us look at in-order solution. So as we know, in in-order solution, left will be operated first, then root and then right. Now if left node is a half node, in such case, removal of left node as well as manipulation of pointer will be easy, but if right node is a half node, if let us say this is a half node, then removal is easy, but the manipulation of root node will be tricky because root has already been operated on and we are at right child of the tree. And because of this reason, we are not going to use in-order solution as well. So which solution are we left with now? Well, the solution which we are left with now is post-order traversal. So let us look at post-order traversal. So as we know, in post-order traversal, left will be operated first, then the right child will be operated, and then the root will be operated. And this will give us an easy way of manipulating the pointers. So what we are going to do over here is we are going to identify whether left is a half node or not. Similarly, we are going to identify whether a right is a half node or not. In that case, that node can be removed, and then since we are operating on the root pointer, then the manipulation of root pointer becomes easy, since we already know whether left or right is a half node or not, and because of which we are going to use post order solution in order to solve this problem. So let us see how we will be able to use post order to solve this problem. So let us say this is the tree which is given to us. Now the post order traversal of this tree will be something like this. So this is the post order traversal of our tree. Now let us see how we will be able to use post order traversal in order to solve this problem. So the first thing which we are going to identify is whether 2 is a half node or not. Since 2 is not a half node, so 2 remains as it is. Now let us look on the next node, which is 7, and 7 is also not a half node, so 7 remains as it is. Now let us look at the next node. Well, the next node is 5, and 5 turns out to be a half node. Now since this is a half node, what we are going to do is we are going to delete this node, and after deleting we are going to return the left child of this node. This is based on this logic which we have discussed. If root of left exists and root of right equals to none, then in such case we are returning root of left, which is the case over here. As you can see, 5 is a half node because left child exists and the right child is empty, because of which in such case we are going to return 7. Now once we return 7, the tree will look something like this. So this is how the tree will look like. Now let us move to the next node. The next node is 4, and as we realize, 4 is also a half node. Since 4 is a half node, then this 4 has to be removed from our tree. So we will remove this 4 from our tree, and we will pass root of right, which is 7, to this tree. So again the tree will be manipulated and the tree will look something like this. And now let us proceed forward. So the next node is 6, and 6 is not a half node. Similarly, 3 and 1 are not the half nodes, and we are going to return the root of this tree, which is 1, and this is how we will be able to solve this problem. So that's the discussion of solution of this problem, folks. Now let us discuss the pseudocode of this problem. So let us say we want to remove half nodes and root of a tree is given to us. So the first thing which we are going to do is we are going to perform post order traversal. So as in the post order traversal, if root equals to none, if this is an empty tree, then in such case we can just go ahead and return root. Otherwise, the first thing which we are going to do is we are going to operate on the left subtree. So let us operate on the left subtree. So remove root of left. Similarly, after operating on the left half of this subtree, now we will operate on the right half of the subtree. So this will be root of right. Now let us look at the actual operation. So the actual operation is basically identification of whether a node is a half node or not. So let us do that. So if root dot left equals to none and root dot right equals to none. So this implies that this is a leaf node which is not a half node, because of which we are going to return root. Now we are going to check whether root of left equals to none. If root dot left equals to none, this simply means root of right is not equals to none. In such case, we can simply go ahead and return root of right. If this condition is confusing, folks, you can also append this condition with and root of right is not equals to none, but this essentially is the same thing because of this condition. Since we have placed this condition first, and if we are at 7th position, then that simply means root of right exists, because of which we are returning root of right. Similarly, if root dot right equals to none, then in such case root dot left exists, because of which we can return root dot left. And if none of these conditions are satisfied, then in such case we can return root. And in this way we will be able to identify whether a node is a half node or not, and accordingly we will either return root dot right or root dot left. So through step 5 to 11 we have identified whether a node is a half node or not, and accordingly we are returning the appropriate node. So once we have the appropriate node returned by this function, we just have to take that node and put it into the left part of the subtree. Similarly, over here, we will take that node and we will put into the right part of the subtree, and in this way, we will be able to manipulate our pointers. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So we are first checking whether it is an empty tree. If it is an empty tree, then we are returning none. Otherwise, left and right child is what we are iterating on. And while iterating, we are also ensuring root.left equals to left subtree and root.right equals to right subtree. And the left and right subtree will be manipulated accordingly using this function. Now let us look at the remaining part of the code. So over here, we are identifying whether this is a half node or not. If it is a half node, then we are returning the appropriate pointers, which is root.right or root.left. If it is not a half node, then we are returning root. So that's the Python code, folks. Now let us submit our solution. So our Python code got accepted. Now let us look at our C++ solution. So the C++ solution is also the same, folks. Over here, first we are checking whether it's an empty tree. If it is an empty tree, then we are returning root. Otherwise, we are iterating on the left and right half of the subtree. And then we are checking whether it is a half node. If it is a half node, then we are returning pointers appropriately. Otherwise, we are returning root. So that's the C++ code, folks. Now let us submit our solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.